recording?
Yeah.
Okay, so this is page 56, two-dimensional figures, geometry, section 1-6. And it kind of thrown in here, but it's something that we need to learn right off the bat in geometry. So we'll look at this figure here. If I make a figure like this is what we call, and this is just an example, all right? This is not what everyone is. This one is called a polygon. Okay? And this is the general name of it, okay? A polygon is a many-sided figure. It does not include the circle. However, we're going to talk about a circle today, so we will include that in our conversation today. Actually, poly means many and gon means angle. So really, the word means many angles, but we say a many-sided figure. Okay, you have been around polygons your whole life, since you're a little kid. You know, they even make little kids' toys as polygons. These are vertices. And I can name this by those vertices. So I would say I would use capital letters A, B, C, D. Most of the time, you can use just 4, but I would use all 5 in this case. So I would say polygon
A, B, C, D, E.
A, B, C, D, E.
So, is there,
Is there like a sign for polygon?
No, there is no sign. There is for certain ones of them, but we haven't got to that far yet. These are called the inside angles of the polygon, and these are the sides of the angle. So the polygon has sides, line segment AB, line segment BC, line segment CD, line segment DE. Oops, that's an E. That's an E.
E, A.
And then line segment EA. These are the sides of the polygon. And every polygon can be different. Okay? Now, they give some on page 56, and I can draw them, but on page 56 they do such a good job. Page 56, they have polygons on the left. They show polygons on the left, and then they show non-polygons on the right. You can see if the sides crisscross, if they intersect, or if one extends out, if they're wavy at all, if they're curved, or they don't complete, they're not polygons. Okay? They're not polygons. We have two, yes?
What, like, if you look at the not polygons,
Uh-huh.
that like a square with a line going up is the way to describe it.
Uh-huh.
What if there was another line that like, connected it?
Yeah, then it would be 2 polygons together. Yep, yep. Okay? So I want to talk about, this one is concave. This is a convex polygon. There's 2 kinds. This is a concave polygon. Whoops, I'm sorry. This is a convex polygon. And this is a concave. And I think of, the way I figured out is cave goes inside, right? Cave. All right. And so this would be a concave because it has a inside thing. Actually, the definition of concave is a little bit better known on the next page, on page 57, when it says, right underneath A, you see in the middle of the page, it says A. The polygon has 6 sides, so it's a hexagon. We'll get to that in a minute. But 2 of the lines containing the sides of the polygon will pass through the interior of the hexagon, so it is concave. Carly, if you take a line like this, and you extend these 2 lines, you'll see that they go through the inside of that, where that would never happen. If you did all the lines of this, they would stay on the outside. That's how we can tell whether it's concave or convex. Yes, sir?
Does it have to do anything with symmetrical? Like,
No, not necessarily. Not necessarily. Okay? Do you understand the difference between concave and convex?
yeah.
Okay. Yeah, it goes in at some point, doesn't it? Okay, one of the most interesting, well, let me define the polygons. You know a lot of them from elementary, okay? A three-sided figure is the smallest one, and it's called a triangle. Okay? A four-sided is not a rectangle, it is a quadrilateral. You need to know how to spell these, and I think you know how to spell most of them just because you've done them before. A five-sided, as one of you already alluded to, is a pentagon, and that's the one I began drawing on. The pentagon is made famous by the one in Washington D.C. Okay, that actually made that figure famous. A six-sided is often used a lot and nobody knows it.
Stop
It's-
sexting him.
No, it's not a stop sign, it's a hexagon. Eight is a stop sign, it's an octagon. Seven-sided is not well known.
Septagon.
I think it's a heptagon, isn't it?
Heptagon.
Yeah, it's on page, there's a listing on page 57 if you want to look at it. It's a heptagon.
Well, that's a Harvard decimal.
And I'm sorry that I started capitalizing there, I'm not sure why I did, but none of them can be capitalized, they don't have to be capitalized. We know an octagon, okay, a nine-sided
Nonagon.
is a nonagon. And a 10-sided is a decagon. Now, I'm gonna give you a 12-sided because it is actually used every once in a while, and it's called a dodecagon.
Dodec.
Yeah, dodecagon. Okay?
What's in,
Yes, sir. Ask.
the last box? What is that? Anagon?
Anagon, yeah, they call it, if it has end sides,
You don't know.
it's called an engon.
So would that be larger than like 12?
Yeah, larger than 12. Yep. Okay. And those are the most, I would say that we deal with 3 through 6, 8, 10, and 12 the most. That's what we deal with. Okay?
What
I would
purpose
say
of
the hexagon is famous, the octagon, obviously we use quadrilaterals every day in life. And triangles. Triangles are important. Yes, sir.
What's the,
Can you explain the N again?
The engon is just anything larger than a 14. So if I say, it has 25 sides, I would say an engon of 25 sides. We just say, or a 25-sided figure. So we don't have a special name for it. Okay? All right, now here's the interesting thing. Equilateral polygons. Equilateral means equal sides. So if I say an equilateral polygon, I mean that all the sides are equal in that particular polygon. This one is not an equilateral polygon because the sides aren't equal. Okay, and then we also have another word called equiangular. Oops. I don't know why I did that. Equiangular, E-Q-I-A-N-G-U-L-A-R, means equal angles. Okay. The reason I bring this up is because we like polygons that have equal sides and equal angles. If these two happen, we have a name for this. It's called a regular polygon, which really throws me. Because there's nothing regular. Regular to me just means ordinary, right? There's nothing ordinary about a polygon that has equal sides and equal angles. In fact, the stop sign is an equilateral, or excuse me, is a regular octagon. It's a regular octagon. All the sides and all the angles of a stop sign are equal. There's nothing really ordinary about it. That's quite a thing, you know. Most people like regular polygons. They think they're symmetrical. They think they're easy on the eyes. They don't like the odd ones, okay? Most generally. There are some people that do. Abstract artists like different sizes of polygons, different sides and things like that. But most generally not, okay? If you take a look on page 57, it says name each polygon by the number of its sides, then classify it convex or concave and regular or irregular. So an irregular polygon does not have equal sides and equal length. So you're gonna begin to do this. You're gonna classify each by the number of sides, whether it's concave or convex, and then you're gonna tell me whether it's regular or irregular, okay? So CJ, looking at A, how many sides does that figure have?
6.
6 sides, so it's called a what?
What? Where are we at?
What?
Okay, I'm on A, on page 57.
What,
A.
1A?
No,
A.
A, not one.
Oh.
Example 1A. Okay, so CJ, start again. It has 6 sides, so it's called a what?
Hexagon.
It's called a hexagon. Is it concave or convex?
Concave.
It is concave, okay? And then, is it regular?
Yes.
No. All the angles are not congruent, okay? All the angles are not congruent. It has to be both angles and sides. Yes, sir?
Are there like half circles with 2 lines? Is that saying that those 2 are congruent?
That's very good. It says that those 2 are congruent, but they're not congruent to the ones with the half arc, 1 arc. Okay, do you see that, Utan? Okay, Utan, take a look at the next figure. How many sides does it have?
8.
8? Okay, and so what's it called?
Octagon.
Is it concave or convex?
Let's see. Convex.
It's convex. And is it regular?
Yes.
Yes. Okay. Harper,
Yep.
take a look at 1A down at the bottom.
But, so if it's not regular, we leave it.
You just say it's irregular. Irregular. IRREGULAR.
Okay.
Harper, 1A is, what is that? What's that called? I mean,
Quadrilateral.
it's a quadrilateral. Is it convex or concave?
Convex.
It's convex. Vex. Is it regular or irregular?
Regular.
Okay. Are all the angles and sides congruent?
Not the sides. So
So
no,
it's
it's
Irregular. All right. Carly, the star there, 1B, we would call that a star, right? Is it, what's it, how many sides does it have? 10, so it's called a
Decagon.
decagon. Is it convex or concave?
Concave.
Concave. And is it regular or irregular?
Irregular.
All right.
Hold
so
up,
we
hold
got-
up.
okay.
Wait, so can you have a concave and regular? Or
Yes. Oh, that's a great question.
No.
I don't know that I could come up with one. I don't, that's a great question. I don't know whether there is or not, but I can't think of one right now.
Because
So
it's always
that's
gonna be like an acute angle,
Yeah,
they'd all have
one's
to
gonna be acute and one's gonna be obtuse, so that's what I think. So I'm thinking no, but I wouldn't bet my house on it. Yeah, Addie?
How is that one not regular? Cause aren't the sides the same with those lines? Isn't that what the
Angles though.
But
they all
have to be
The angles, there are angles inside, so if we look at the star.
The outside angles.
Okay, okay, so there's these angles are congruent, but then there's this angle here too, okay? So that would not be regular. That's an inside angle also. That's a great question.
So
Good.
it's irregular?
It's irregular. Yeah. Okay. So we deal on, if you look on page 58, we deal a lot with 4 basic figures. We deal with and now these are getting specific.
A circle?
We deal with the triangle, a square, a rectangle, and a circle. By the way, a regular quadrilateral is called a square. It is. It has a special name. So we deal with these. So the first one is a triangle. Okay, we deal with a triangle a lot. And so what we do is we teach students, hey, this is how you work with it. We're gonna look at 2 areas. We're gonna look at perimeter. And what's perimeter?
outside.
You add up all the
All right, you add up all the sides. So the perimeter is,
S plus S plus S.
is that what they said?
Yeah.
S of 1.
Oh, it
plus S
says B for
B plus
base.
C plus D.
Okay, I'm just go S1 plus S2 plus S3.
Yep.
Okay, I didn't know how they do it. They did, all right. Now, also, the triangle has what we call a height, correct?
Yeah, yeah, yeah.
And we use the height, it's a perpendicular distance from a vertex to the opposite side. Now, I'm assuming that you know most of this. So, to find the area, it is 1/2 the base times the height. Remember, the base is what the height is perpendicular to. Okay? So you can just look for the height and the base will match it, alright? The square is awesome. The square is awesome, it has all four sides equal. So this is I'm gonna write square, we've already written triangle, but we haven't written square. All the sides are equal, all the angles are equal, so it's regular. The perimeter equals, 4s, right? 4 times one of the sides. You with me, Hart?
Yeah, I'm with you.
Hold
And
up,
then area equals side times side, which is side
Side squared.
squared. Okay,
Wow, where'd you get 4, 5 from?
4s. It's not 4, 5, it's 4s. S stands for side, 4 times sides, right? Find it all the way around it, right? Okay. And then we have the rectangle. I have not written this one either, so I will write it. It is rectangle, rectangle. Opposite sides are congruent, which
LW.
means this is congruent to this and this is congruent to this. So the perimeter is 2 times the length plus 2 times the width, because you have 2 lengths and you have 2 widths.
Yep.
And then the area is
L times W.
L times W. Some people call it base times height, it does not matter, it's L times W, or base times height, whatever. Okay, the last thing we're gonna talk about is circle. A circle is not a polygon. It is not a polygon. It does not have perimeter. It does have area. Its perimeter is called circumference. It is, the circumference is equal to 2 pi r, or pi times diameter, right?
Yep.
You can use, when you use pi, you use your pi button on your calculator. You don't use, cause that'll take it out a lot of places, and then you round it. The area is pi r squared. Now, we talked a lot about r, and I haven't defined anything, have I? This is the diameter, which is the full length through the center. This is called the diameter. This is called the radius, which stands for r. This is the diameter. The diameter is twice the radius, so if they should happen to give you the diameter, just divide it by 2 to get the radius. Yes, sir?
What was the formula that was like 3/4? Was it that?
That was a sphere, I think
Oh,
you're thinking of it.
sphere,
Yeah. Yep. Yep. This is what, then that's 3-dimensional, we're talking 2. Yes, sir?
On your calculator, you take radius squared times pi, right? You don't take, or you take pi
Yeah.
times the radius
So-
and then
so-
square it.
Just to throw this at you, if I had a circle, all right, and let's go ahead and just, the diameter is 15, okay? Let me just throw this at you. The circumference is, we would take 2 times pi times 7.5. Okay, so give me that to the nearest 10.
Where's pi?
Pi is.
Yeah, press
Got
second.
it, okay?
47.
47
Yeah.
point what?
1.
Alright, 47.1 units, right?
E.
Alright, I don't have a unit up there, so we'll just say units. Alright, so the area is 2 times pi times radius squared, which is 7.5. No, it isn't. It's pi r squared. My bad. I was thinking I was still on circumference. It's pi times 7.5 squared.
Okay.
Alright, so I would take pi times 7.5 squared.
176.7.
176.7? Okay. 176.7 units squared, right? Okay, units squared. That's the difference. Alright, so all of my perimeters will be of the unit. Inches, feet, millimeters, blah, blah, blah. All of my areas will be
Squared.
squared, units squared, feet squared, okay? Alright, let's just do, on page 61, let's do 11 through, 16 in class. We'll do 11 through 16 in class. Alright, so, and then we won't put them on the assignment, how's that?
Amazing.
Alright, Jaws, you don't have to write these down, let's just do them in class
Yep.
orally.
Oh.
Okay, so Jaws, name each polygon by the number of its side, then classify it as convex or concave, and then regular or irregular. Alright, Jaws, what is that called?
Number 1, okay.
Number 11.
Oh, number 11, okay.
Yeah,
The triangle.
It's called a triangle. Is it convex or concave?
Convex.
It's convex. Is it regular or irregular?
Regular.
All right, we're good. All right, number 2, Gigi. What is that? How many sides does it have?
14?
No.
No, I did not count the right. 1, 2, 3, 4, 5, 6, 7.
7. Okay,
So-
so it's a what?
Hex,
It's a what?
hextone.
No.
Look at your notes.
It's a HEPTAGN.
Say it.
I don't know how to say it.
Heptagon.
Heptagon.
I
Heptagon.
was like,
There's no X in there.
Okay.
Hextagon.
Okay,
Hex.
heptagon.
Hex.
Is it concave or convex?
It's concave.
Concave, and is it regular or irregular?
Irregular. No, yeah, irregular.
Which is it?
Irregular.
Irregular. The sides are all equal, but the angles are not. Okay,
Oh, the sides are
so Kyle, number 13, what is that?
That's the hectadecimal.
How many sides does it have?
10.
No, it doesn't.
No, it doesn't have 10. Count them
1,
again.
2, 3, 4, 5, 6, 7, 8. That's an octagon.
That's an octagon. Convex or concave?
Concave.
And is it regular or irregular?
Regular.
What did you say?
Try again. It's just like this star. These are equal, but what about this angle?
Oh.
So it is
Irregular.
irregular. Utan, number 14.
That is, let's see, quadrilateral,
Quadrilateral. Convex or concave?
convex,
And is it regular or irregular?
irregular.
Irregular. 15, Halloween, right? Bobo. Kind of looks like a pumpkin, doesn't it? So
Yeah.
what is that, Bobo? How many sides does it have?
It has 11 sides.
It has 11 sides. So if you look at the chart, which I didn't put it on there, it's called a
Hindagon.
hindagon. Hindagon, something like that.
It is irregular.
Concave or
It is concave.
concave? All right. Bless you. Okay. And Abby, number 16.
Pentagon.
Pentagon, concave or convex?
Convex.
And regular or irregular? It is regular. All right. Very good. Okay.
So the only way, if concave is gonna be regular, is if it has your arcs going on the outside, and
We
they
have-
have to be one.
We haven't found that yet. The concave was regular. We have not found that yet. That was the question that Harper
So if you
said.
don't know, Kyle, you're pretty much just safe to put irregular if it's concave.
Right.
Yes.
Okay, let's take a look at number, now 17 through 22, you just find the area and the circumference, and let's round to the nearest tenth. It says round to the nearest tenth, if it needs to be rounded to the nearest tenth. Now let's look at 25, 26, 27, and 28. Would you read those directions for me? Carly, would you read those directions for 25 through 28?
Graph each figure with the given vertices and identify the figures and find the perimeter and area of the figure.
All right, so let's go ahead and graph these. Let me show you, you need graph paper. Let's go ahead
Oh,
and do
no arts.
25. Oh, Greeley's gonna need graph paper too, isn't she?
Grant was getting her science, so.
I'll try to remember to give it to him.
I got one.
Oh, no, I can't give it to Grant because he's not here. You got one?
Oh.
Yeah. Oh,
What are you taking all of them?
I didn't mean to.
Stop. What are you doing?
My bad.
Okay, Josh, could you turn the video camera so we're
Yeah.
going to. Okay, let's go ahead and look at this graph. 25,
That's
Bo,
what we're
would you
to
read the points to me?
D is -2, -2.
-2 and -2 is D,
Yep.
okay?
E is -2, 3.
Okay,
And F is 2, -1.
all right. You see that?
That was the bottom one's F.
This is that. All right? Okay, so what we need to do is find the distance, right? Cause the first thing it says is, well, what is this first? It says identify it. So what is this?
A triangle.
Triangle. It's So it's a triangle. Do you remember the distance formula?
Oh, we have to use that?
Yes, we have to use it. Remember the distance formula?
Yep.
Okay, alright. Can I, and then the next thing it says, let's go, it says graph the figure, which we did, and identify the figure, we did, then find the perimeter area. So let's go ahead and find that, okay? Here is this base, right? How long is it? 1, 2, 3, 4, 5, it's 5, right? But I can't find these, can I? No, I cannot find them. Okay, so what do? Well, I gotta use the distance formula. So I gotta find the distance from here to here, and I gotta find the distance from here to here. Yes?
From E to F, can you count it? Because
No, it's because it's a diagonal.
But you can
Oh.
count them.
Yeah, but that's not a square, that diagonal's not equal to a side.
Okay.
Okay, so can you tell me the endpoints of each, let's start with D. Let's start with D. Bo,
What?
can you tell me the coordinates of D?
Negative 2, 2. Negative 2, sorry.
Okay, -2 and -2, well, I can just see. E is a -2, 3, and then F is, 2 and -1, right? Okay, so I wanna find, let's go find EF. So we're finding the distance between E and F. So the distance, remember this?
Yep.
Is, x minus x, right? So a -2 minus 2 quantity squared plus 3 minus -1 quantity squared. Is that right?
Yep.
Yes.
So that is, plus a negative
Negative
4 squared is 16. So we have 16 plus 16, right? I got the square root of 32. Is that what you got?
Wait a minute. Why don't you have F in there?
Cause you can't put
Oh,
3.
I
in
meant
there, can
D
you?
to be distance, not, D is distance, not the letter D,
Oh.
sorry. So I used the distance from E to F. I'm doing E to F, right? So Harper, I took a -2 minus 2, -2 minus 2, and I squared it. 3 minus a -1, and I squared it, the distance formula,
Oh, I got it.
okay? And so this is, -4 squared, which is a positive 16, and this is 4 squared, which is positive 16, which is square root of 32. Okay, alright, so we're gonna leave it like that for right now, okay? Alright, we're not gonna simplify, we're just gonna leave it, because I'm gonna have you do these in decimals. The next thing I'm gonna do, so this is a square root of 32. The next thing I'm gonna have you do is find DF. Alright, DF.
Wait.
So I'm going from here to here. So I'm finding the distance between these two.
Wouldn't
Did I mess up?
wouldn't the -2 plus or minus -2 be 0 if
No.
you would change it?
-2 minus 2 is a -4.
It was 2, and we made it negative 2.
Yep, I subtracted 2. I took a -2.
Oh, we're doing.
Minus 2, I'm
F.
doing, yeah, E and F, now I'm doing D and F. We ready? Okay. Are we ready, CJ?
Yeah.
Okay, so now I'm doing D and F, so I'm gonna take the square root of a -2 minus 2 again, right?
Yeah.
And that's squared, but now I'm gonna take a -2 minus a -1. -2 minus a -1, square that. -2 minus a -1. So I get the square root of a -4 squared, which is 16 again, and this is
1.
-1 squared, which is 1. So now I have the square root of 17. So this is the square root of 17. Okay, so let's find perimeter and find area. You ready?
Yeah.
Okay, let's start with perimeter.
Do we find it? Do we find DE?
No, I already found it,
You
because
know it's 5.
I can
Oh,
just
we can
count
just
that
count.
one because it's on
Oh.
squares. I think most of them, one of the sides is on, you know, is you can just count. Okay? Alright, ready? Okay, so the perimeter is 5 plus the square root of 32 plus the square root of 17. So you're gonna put 5 on your calculator, you're gonna put 5 plus the square root of 32 plus the square root of 17, and to the nearest tenth, tell me what the perimeter is.
Square root.
Yes, Uton.
It would be 11.
Did I screw up?
No, it should be 14.7.
Should be 14.8, shouldn't it?
Or,
If I
yeah.
round
14.8, yeah.
Units.
Stanex air. Come on.
What'd you do wrong there, Uton?
Come on, big hoss. I did something wrong.
Is this one?
I got 11.
It's square.
Yeah.
Yeah,
It's
no,
a-
five is-
Did I screw up?
I got a Stanex air.
Yeah, it should be
Like, so,
14.8.
like, what is it? Do five.
I got
5
14.
plus.
So I have to use here for this.
Second. Plus second.
That
So I have to use
No.
Jazz, we used the
Yeah,
wrong
I
one.
got 14.8.
Jazz, we used the wrong one.
Second.
Okay.
And then.
Yes, you have to
X-
finish the parentheses.
Yes.
So you have to go 5 plus
No, and now the.
square root,
X squared.
14.8.
Now
square root of
32.
17
And then do
finish
parentheses
the-
again.
parentheses plus
Behind 32.
square root of 32, finish the parentheses.
What?
Okay, you gotta finish the parentheses on the square root,
Oh.
okay?
That's a lot of work.
Did you not get it?
I got it.
Okay, area is a little harder.
14.8 units.
Yeah, units.
14.8 digits.
Okay, now, you need a height. The best height to take is this one right here. I'm gonna put it in red. So you can see it.
Blood and guts.
Because it's the perpendicular distance, I know it's perpendicular, and you can count it. Because it goes from this vertex to this side. If they have a side like this, you can do the height straight on with a horizontal line. So this one is 1, 2, 3, 4. This is 4 units long. So
Why don't you just use that 5 you already have?
that's a side, that's not a height. And it's not perpendicular to the other side, so you can't use it. A height has to be perpendicular to the other side.
No, it's 1/2 based on.
It can be sideways like that.
Yes, it can. Yes, it can. Yeah? Bo,
Will there always be a perpendicular?
yes, on the ones they give you, yes.
But not always.
Yeah, well, no, on every triangle there's a perpendicular. I'm just saying you can count them on this one. You won't have to find distance.
I'm gonna base
Okay.
something.
Now we're gonna do 1/2 base times height. 1/2
So we're gonna get 10.
times base. Our base was 5 and our height is
4.
4. So 1/2 of 20 is what?
10.
10 units squared. Actually, that was easier. I thought it was gonna be a little tougher than that. Okay? All right. Let's give you your assignment. Would you shoot that over to the assignment, the camera over there to the assignment? It is page. I'm gonna change this. It's different on here. I'm gonna go ahead and change this. Okay? It is page. I better look at it. 62. Since I changed it, I'm gonna cut it down since we did some of them in class. Page 62, numbers 17 through 26, and 25 is already done, correct?
Yep. So
Alright.
just
Okay, that's all we're gonna do. Alright, so I cut that down from the original assignment.
thank you.
Alright?
Oh, you can
Thank you.
zoom in.
Alright, what's that?
Oh, you can zoom in.
Did it, really? Did you do it without shutting her off? Alright, okay. Now you just do this? Oh, okay, cool. We're gonna have to start having you guys videotape for professionals. Alright, that is due tomorrow.
Say videotape.
Due tomorrow.